Alright guys, there's seems to be some confusion with the at least problems. There's always some confusion with these at least problems. So I'm looking at chapter 5 section 3, and I had some people ask about number 11 and number 15, and that should give you a good idea about these at least problems. Let's work through number 11 and 15. So I have two cheeses are chosen at random. What's the probability that both cheeses are pasteurized? And they told us that pasteurized, 87% of the cheeses are classified as pasteurized. So if I have two cheeses picked at random, what's the probability that both are pasteurized? So I'm going to bring up my calculator I have, and this would just be saying 0.87 times 0.87. So I want pasteurized and pasteurized, and a lot of times means multiplication when we're doing these probabilities. So that gives me 0.7569. 0.7569. Woohoo! All right. The next question says eight cheeses are chosen at random. What's the probability that all 8 are pasteurized? So again, this would be 0.87 times itself 8 times, which is the same thing as just using exponents. I could have done that on the one up above and said 0.87 squared. So I'm just going to raise it to the 8th power. So 0.87 raised to the 8th. And I get 0.3282. 0.3282. Fantastic. Now is these at least problems. What's the probability that at least one of the 8 randomly selected cheeses is raw milk? Well, in words, what that means, at least one is raw milk. It means one could be raw milk, or 2, or 3, or 4, or 5, or 6, or 7, or 8 could be raw milk, or the cheeses could be made of raw milk. What it does not mean, see, I don't want to figure out all those probabilities. So what I'm going to do is just find the one thing that it's not. I'm going to find out what's the probability that 0 use raw milk. Well, the probability that 0 use raw milk means that all 8 of them were pasteurized. And I've already figured out what pasteurized is. It's a 0.3282. So if I do 1 minus all pasteurized, 3282, that's going to give me the probability of the at least one uses the raw milk. So 1, 2, 3, 4, 5, 6, 7, or 8. So I don't have to find out those 8 different probabilities. I can just find the one that means 0 used raw milk, which means all 8 were pasteurized. I know what the probability that all 8 are pasteurized, 0.3282. And so if I don't want that one, but I want everything else, I do the complement, which is 1 minus 0.3282, which gives me that 0.6718. Woohoo! It would be not unusual, right? Because our unusual mark is less than 5%. So let's jump over to 15, and I think started this one. Let's just start over. I'll just keep on hitting check answer and done and check, final check, and oh, missed it. Okay, similar exercise. The probability that at least one has not driven a car. We're picking 2 people. 34% said they have driven a car while under the influence of sugar. The probability that at least one has not driven a car. At least one. So that means one has not driven, or 2 has not driven, but not 0 has not driven. 0 has not driven means both did drive. And we know what the probability that both did drive. It's 34 on each one of them. But I don't want that one. I don't want the probability that 2 have driven. I want at least 1 has not, which means 1 has not or 2 has not. So I'm going to find out the probability that 2 have, and I don't want that one. So I'm going to say 0.34 times 0.34, and I don't want that number. I want the other two values, which means 1 has not driven or 2 has not driven. So I'm going to do 1 minus the 0.1156. That finds your complement. 100% minus the 11%. So I get 0.8844. 0.8844. Woohoo! Now, the next one is saying that at least 1 has driven. So that means 1 has driven or 2 have driven. But it doesn't mean 0 have driven. 0 have driven means that they both did not. They both did not. So what we have to do here is find the complement of our 34%. That's 66%. 66% have not driven a car while under the influence. So if I'm picking the two randoms selected and I'm looking for at least 1 has driven, so that's 1 has driven or 2 has driven, let's find the probability of 0 has driven and subtract that from 1. So 0 has driven means 2 have not driven under the influence. So I'll do the 0.66 times 0.66, and I want the complement of that. 1 minus, minus the 0.4356. So I get 0.5644. So I do understand these are a little rigorous, right? But they are good questions. It's a lot easier than finding out the probability of 1 and then probability of finding the second one and then adding those up. Just makes for a little bit easier. So, hope this has helped, and y'all have a good day.